Hello, hello, hello. Mabuhay. My name is Ron Dagdag, and today I'm going to be talking about AI to the edge with Azure Percept. Let's get started. Have you heard the phrase, see no evil, hear no evil, speak no evil? Remember the three wise monkeys? Uh, I got interested in learning more about this, and because I remember growing up and I've heard this phrase before, and the way I understand it is, when you see something bad, just cover your eyes, and you see something, when you hear something that's inappropriate, just cover your ears, and you know, just don't talk about it. Don't talk about inappropriate things. And I wanted to know like where did it come from, and I found out that it came from Japan. It's a play of words. The words was misaru, kikasaru, and iwasaru, which is that's why they became monkeys. Um, and it is from a temple in this Toshogu temple in Nikko, Japan. That's where it got started. It's a wood carving on one of the temple doors. All right. So our agenda today, we'll be talking about what is AI enabled Internet of Things, and then I'll talk about with what is this Azure Percept uh, and the capabilities of uh, Azure Percept, and we'll do a little bit of demo. All right. When I wanted to start learning about Internet of Things, and of course, I searched a little bit online. It's like they always ask, do you want to try it in Arduino or want to try these Raspberry Pi?" And there's like all these different choices out there of where you can run your, and where you can have your Internet of Things device. And then if once I started doing that, and I wanted to learn more about computer vision. Of course, there's a lot more, especially if you're doing some machine learning. And there's the languages, the platforms, the tools, data ingestion. And there's a lot more things that you have to think about when you're doing some computer vision and machine learning. It got me to a lot of questions in my head, and so let's clear it up a little bit. Let's start with what is Internet of Things. Internet of Things is connecting, to the internet via the physical world via sensors. It was coined by Kevin Ashton back in 1999, and it's about any device that interacts with physical world around it and connecting it to the cloud or the internet. Of course, you're most likely familiar with it because a lot of the smart homes that are available out there, those are Internet of Things devices. There are two goals that you have to do when you're creating an Internet of Things application. One is remotely monitor these devices out there where it's gathering data, edge processing, and knowing the status of that device. And then another one is controlling that device. It's either you're trying to send commands, let's say rebooting that, or sending some of device properties. When you think about, the thermostat in your home, you can remotely uh, send commands to it to set a certain temperature, for example. And of course, whenever we talk about Internet of Things, a lot of it is the connection between the cloud and then, of course, these edge devices. Edge device, in this case, is how close it is to your users. So where do you do your processing? It's either you do some of your processing at the edge. Of course, sometimes you do it at the cloud, and sometimes we call it, the one in between them is the fog network or some of the nodes. And when you're trying to deploy some of your application, start thinking about lots of devices. So let's go back to programming. When we first, let's say your boss wanted to ask you to do, let's say in this case, let's create a calculator. And there are two things that you would ask him, right? What is the input and what is the algorithm to do this calculation? And then, of course, you can spit out the answer. So, and all that processing, however you want to display it, and however you want to take the input, and then you build and write your program, which is your algorithm. In machine learning, uh, it's like it's flipped. Uh, the goal is you want the computer to learn or to figure out the pattern based from input and answers, and then create an algorithm for you. So the goal is to learn based from that input and answers. And of course, you need lots of examples so it can find the right pattern so to create the algorithm. So as a machine learning primer, programming on the right side where you have your input, algorithm, and answers. On the left side where you have the machine learning, where you have input, answers, and then algorithm. In machine learning world, we call that training data. That is why it is important to have lots of training data. Then you pass that into your training framework. A good example of a training framework that you hear out there is like, TensorFlow or Keras or PyTorch. And then each one of these training framework would generate a model for you, and then that's what you would use that in to integrate with your application. And in order to use that model, you need in machine learning world we call that inferencing, and then you need an inferencing runtime to use that model so that it'll give you the predicted answers. So when I first started to learn about machine learning, this model kind of helped me understand what the whole purpose of this, what we're going to be talking about today. We talked about this Azure Percept dev kit. Azure Percept dev kit is an IoT device that's specifically built to connect to Azure, and there's three components for this Azure Percept dev kit that is currently available right now. If you go back to this form right here, the dev kit, the Azure Percept is actually on this side over here, where on the IoT device it's doing the inferencing. So there are three components on that dev kit, which is the Azure Percept Audio, Azure Percept Vision, and Azure Percept Trust module. Remember, most likely you walked around a lot of these shopping malls or a lot of the public areas, and they have these cameras, security cameras. And of course, these security cameras, once it starts recording, it's always watching and it's always recording. That's not what we really want in our systems, in our Internet of Things systems. What we really want is to where it would do some processing of that video locally, and it limits the recording, the only important things that it can record. And that's when we start talking about this intelligent video analytics. So Azure Percept Vision, out of the box, it has some AI recognition for common objects that does not require any coding. It has this vision processing unit that has camera already integrated with it. And it's an 8 megapixel camera running at 30 frames per second. And it's an RGB camera that can do the processing for you. And of course, whenever we're recording something, um, when you press the record button, it start always listening and it's always recording. And of course, that's not what we really want on some of our in our systems, because it's what we really want is to have some sound processing at the edge where it can limit the amount of what it can listen, what it can record, and make it context aware. And that's when you start uh, hearing about these smart assistants. Most likely you're familiar with it because Google Home, Siri, and of course Madam A, which is the Amazon Alexa devices. They can listen to that keyword and then the wake word, and once they hear the wake word, that's when they can start the recording and then send that data to the cloud for further processing. So Azure Percept Audio allows you to create this smart device, or this smart assistant, where it has the microphone that has 180-degree far field at 4 meters, and it has the visual indicator and components that is part of that. And of course, a lot of these even websites or phones, they always broadcasting and always tracking some of the usage and all that. And what we really want is not to do a lot of the tracking and send outside and send it to the cloud. What we really want is to do some data processing at the edge and limit some of that information being sent to the cloud. And that's when we start talking about these intelligent edge. Uh, in, and so this Azure Percept Dev Kit has this processor that is for these IoT device that is based on an NXP IMX8. It has Wi-Fi, Bluetooth, Ethernet, so it allows you to be able to do. It's good enough to do some processing at the edge and do some intelligent analytics or intelligent edge. And I will demo more about that later once we do the Azure stream analytics at the edge. Azure Percept Studio is the one that onboards some of these or connects these dev kits or this Azure Percept uh, IoT devices to the cloud to manage them. So it has some delightful onboarding, integrated experience. It allows you to be able to do a no code or low code, and then it also can do advanced, and you can use it for prototyping and also the deployment on these. So why would we want to do AI or even machine learning on the edge? One is low latency. If you think about these IoT device, it's collecting camera frames, right? It has video processing, and if you want to do processing on that video really fast, you want to do your machine learning or AI at the edge. Also, it costs less if you do that if the device is processing, or if the IoT device is processing some of the camera frames. It can scale because now you're not sending a lot of videos. It costs less, or you're not sending a lot of pictures or images to the cloud to get processed. It gets processed locally, so it's more scalable that way. And of course, it is flexible. If the internet connection is down, it's still processing some of your data, and it it can cache to the cloud later on, and you're only sending the results. Flexible too, because maybe uh, there's you know there is some security reasons you don't want to send some of the images to somewhere else or ship it outside of its network, and so it becomes flexible that way. Maybe there's a personal there's images, or there's improper images or something. So and all that machine learning, um, there is also a what we call transfer learning. Transfer learning allow us to be able to create models not from training from scratch, but we use the transfer learning to uh, to create another model based from something that is pre-trained. So, for example, uh, if you're usually when you're creating a machine learning model, when you're training from scratch, you need lots and lots of photos. In this case, lots of photos of cars, and it'll learn and we'll train the we'll give it a bunch of example. It would learn the features of that car based from that images, and it would try to detect, okay, yeah, that is a car versus as compared to truck and bicycle. Most likely that's what it is. But transfer learning, it gives you like data, but instead of learning from scratch, you train it on um, something that is a pre-trained convolutional neural network. Like in this case, it was using, it was pre-trained for cats and dogs, and you're reusing it to be able to fine-tune the network weights to be able to detect, if it's a car or a truck, that kind of thing. And that's what custom vision is actually providing you, in ability to create. It's using transfer learning to create a new model, a custom vision model, and where you can upload some of these images and then tag them. Like in this case, I have some images of fruits and I'm tagging them. These are images of fruits, and then I can train them in the cloud in Azure, and then you can download that model. So, and I will demo today when do we use this custom vision service and how does it connect to Azure Percept, and we'll go more about that. Uh, and Azure Percept has it's using IoT Edge, where you can actually have all these different modules and Azure, there's an IoT Edge module Azure Marketplace. So where you can add Azure Stream Analytics, you can even put SQL Edge uh, on that device. You can do an event grid. Maybe you can install a SQLite or a blob storage at the edge. You can install Node-RED running it, and they're all containerized. That is running on that on these Azure Percept dev kit, and also the it could be deep stream. You can do anomaly detector, those kind of things. So we'll go through a few things. I will demo today Azure Stream Analytics on the edge, and uh, and let's get started. So let's look at Azure Percept Studio. What we'll learn on my demo is, you know, what it looks like. How does it connect to IoT Hub, custom vision. You'll hear me talking about OpenVINO and Azure Percept I module. Okay, so once you set up, the great thing about Azure Percept is that it has the onboarding instructions, and they made it really simple in how you can connect it to Azure, and how to onboard each one of these IoT device and connect it to Azure. I am not going to demo that today, but I'm going to demo some of the features of the Azure Percept Studio once it connects to the cloud. So I have my list of devices over here where you have these my device name, Percept device 01. It tells me that it is connected, and it's connected through IoT Hub. And let's go through this device. On this device, it gives me some device information, who is the manufacturer, uh, and what is the model, what is the software version. It is actually using an ARM processor. Um, and then you have a tab for vision and speech. Vision, this is where you can actually capture images for that project. You can view device stream, deploy custom vision project, and then deploy a sample project. So what I'm going to do right now is out of the box, I'm going to deploy, and they give you the sample vision model that is available over here. And I'm going to deploy this general object detection. Okay. And I'm going to click on that. And what this one would do is it actually would send the sample model to that device, from cloud to that device. And if you want to view what the camera is seeing right now, I can click on this view device stream and then view stream. And in order to view what the camera is seeing, uh, that's where it is. So it's looking at this right now. This is where the camera, it has to be on the same network in order to view this. So your computer and your your Percept had to be in the same network, then you can view the live stream. So what I'm going to do right now is I have my monkey statue over here. Notice how it kind of detected that it is a teddy bear. I don't think that's a teddy bear. That is not teddy bear, but that's part of the sample module, because we did deploy a general object detection. So it'll do that, and every time you see the bounding box, then what it's doing is it would do the inferencing on that device, on this IoT device, and then it would send the output of that to IoT Hub, and then from IoT Hub you can do your processing however you want to export it. I am exporting this data to a blob storage, which we will look later on and see if, what that looks like and what it does export. Okay, so since I have the view of this, what I'm going to do next is I want to capture images for a project, meaning I want to take a picture of what it's seeing right now. And I have a project that I created. This is a custom vision project. You can create your own custom vision project if you go to customvision.ai, or you can click on here. So once you have that project, you can take a photo. And what this one would do is it would take a photo of that of what it's seeing right now. It would send it to the custom vision project. Custom vision, if you're not familiar with it, you can so what I did before is to capture some of these images, and once you have these images, then you can process them. If you click on tagged, this is the image that it did capture at the moment, and I'm going to annotate. Annotate meaning I will draw a box that says, hey, this image right here, or this bounding box right here, represent tag. I can create a tag, but in this case, it's here. So now that I tagged that one and I'm finished with it, I can close this window, and now everything that's tagged, I have 67 images that are here, 72 images that are see, and then 80 images that are speak. And I click train and then do some quick training. And what this one would do is you would use transfer learning to create a new model. And once it does that, now I can deploy it, since this Percept audio is connected to this custom vision project. I can deploy this project. In this case, I would do see here, speak no evil. And since I've already pre-trained an older version of this, I can deploy the different iterations. So typically each one of these are the models that I created in the past. based from those pictures. And every time I would add more pictures and I would annotate them and create those bounding box, I can retrain and get a better model. So in this case, I can deploy this model. And so what this one would do, that is still running, is it would deploy the model onto this device. So you notice how it says loading model. And we'll wait for a few seconds. It just depends on how large is that model. What it's doing right now is actually downloading from Custom Vision. It's downloading that model and it's saving it into that device and then setting it up to where it would be part of this Azure I module to do some processing. And notice how it would gives me this bounding box and it started running, and now it recognized that, hey, this is here. Let me try to put another device or another monkey over here. Now this one is being detected as speak, and then I'll put another one, and now there's two of them, and it's detecting both of them at the same time. Okay, let me try to remove that. Okay, so right now it's going to be running, but every time it would see and it would process that, and notice how it's processing it almost in real time, because as it sees it, it starts sending the results. And the results of that, the result of it, it would get sent to the cloud. How is that possible? Um, let's let's look at it next. So we did talk about the vision side where we capture, uh, we reviewed the device stream, and once we view it, we captured some images for this project. We train a new model, and then deploy that custom vision project to that device. We also deployed general object detection to try it out. Since this is connected through IoT Hub and the instance of IoT Hub, you can click Open Device in IoT Hub. And since this is an edge device, if you're not familiar with uh, an edge device have it's running actually Docker containers on each one of these is actually a Docker container. It's a custom module, and notice how there are a lot of them running. These are some of the what is responsible for processing some of your data that's seeing from the camera. Um, so let's go through each one of this. There's an edge agent and an edge hub. The edge agent is responsible for the communicating and making sure that the status is connected to Azure. The edge hub, that's kind of like the communication between not just one module but also responsible for sending it to. It's kind of like local IoT hub at the edge that is running. The web stream module is responsible so we can see this web stream, and it's using RTSP to be able to connect to that. That's for the video processing that is on there. And of course, you have these other modules right there. The important part here is the Azure I module. Azure I module, that's where it reads the frames from the camera and then does the AI, the machine learning side of things, where it's doing the processing for 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 the detection, the vision detection, and then that gets sent out from that module to another one. There's also an image capture module. That is the one where we click take photos and send it to custom vision. That's the one responsible for taking the photo and sending it to the cloud, and knows where to upload uh, to uh, to Azure Custom Vision. I've also added few modules here, which is the Arduino module and then this Azure Percept demo. This Arduino module, what I wanted to do, and I'll talk a little bit more about this, is to be able to control and connect an Arduino to these um, Azure Percept and do some uh, to have some alerts or some beeping that is happening. So let me kind of show you how I got that connected, and if you're interested on it. Okay, let's see. So uh, this is a buzzer, and this is an Arduino, and this Arduino, I have a wire over here that is connected to um, to a USB port on these um, Azure Percept, and this is what this Azure Percept dev kit, what it looks like. Let's see if I can zoom in that a little bit. So it had the yeah, that is the processing unit, and I connected the camera on the other side. So that's connected via USB, and I have a container running on this device that communicates with Arduino, and that can send to a buzzer. So it's one custom module, and trying to understand to learn it. And that, I don't know if you, whenever I have a an object that is on that screen and it detects it. Let's see if it'll show up here. I don't know if you hear a faint buzzing sound, and that is coming from the Arduino uh, buzzer. That every time I read or it receives a message from the Azure I module, it would start processing on that other container to start the beeping. So, okay, let me turn that off. So I took that out. Okay, let's go back to the presentation. Okay, so what just happened, I did demo what Azure Percept Studio is and how it kind of connected to IoT Hub, and kind of talked about all the different modules that's running there. I did demo a little bit about Custom Vision and Azure Percept I module. So this is the one where I was telling you about. I have the Azure Percept camera where it can detect the monkey. It goes to this Azure Percept dev kit. I also have on this dev kit, on this trust module, um, connected to an Arduino Uno to have the buzzer. And also I have Azure Edge, Azure Stream Analytics on the edge running here that sends data to IoT Hub. So Azure Stream Analytics on Percept, since it's an IoT Edge device, so it would process data that's coming from the camera as it receives data coming from the camera. Since it's receiving it as a streaming data, it can process it and collects some of the reports, and then based from there, send it to IoT Hub rather than uh, before. So the whole idea is I don't have to send all the inferencing results to the cloud. I just only send the summary of the results. So let's dig deeper on how this one works. Of course, in order to do Azure Stream Analytics, the edge for using Azure Percept, you go to the cloud, to Azure Cloud, you have Azure Stream Analytics, you create a job, and then you specify a storage where you can store, where you can have the job definition. And then now you can specify on the edge device knows how to read or download from Azure storage that Azure Stream Analytics job, and then it will run it on this IoT Edge runtime. And we'll do more about that. So typically, whenever you run, these from iModule, every time it runs and process the frame, and this is the typical output of it. It will say neural network. What is the bounding box? Remember on that demo. Let's see if I can show again. On this one, there is that bounding box around it, and the bounding box, it tells you the result of that edge processing, and then what is the label, right? So that's what it would look like. Of course, in this case, it won't say person; it would say, speak, and then it would give you the confidence and then the timestamp, and that's what gets sent to IoT Hub every time out of the box. But what I did was, use Azure Stream Analytics Edge module so that instead of sending this pre-processed data, um, that would only send the summary where you for the and you do the tumbling window where you specify every 15 seconds count the number of times that that it sees speak and send that. So how you would do this is you would have these query, and what this query does is, as it comes from Azure Percept, the Azure I module for this Azure Stream Analytics module, you have this IoT input, and this IoT input looks something like this. And you would grab these and get the array elements and pass it as data. Then now, and now it can identify the data, that array value, that confidence, and you can specify anything that's greater than 0.6. That's going to be the output of this query. So just to go back and kind of read where it's coming from, right? So this reader query right there is coming from here, right? And this reader query kind of gives you the label and then the timestamp. It reads the label and the timestamp so that you can have those data set. And then based from there, you can group it by label, and then you can do the tumbling window that says every 15 seconds, you query it, identify, hey, there's the values that I can say the confidence that is greater than 0.6, and then you would have that as your output. So this is going to be your output where you specify label and then the count of what that result is. You can read more on the documentation if you want to follow through on how you can deploy this on this tutorial, deploy stream analytics. But that is what's happening there. In order to convert this data into this data, I'm using this query to process the data from Azure I module, go through these Stream Analytics Edge module, and then have this output label and count. So let's do a little bit of demo how this one would look like. Okay. So remember, I did tell you that we have these modules, and the Azure I module, that's the one that uh, process your video frames and converts it to a data stream or a output stream. And what we have to do here is we have to send this Azure I module, the output of it, into a different container, to a different processing. So if you, what I did was to click on this set modules, and the set modules allows me to add an IoT Edge module, a Marketplace module, and Azure Stream Analytics module. IoT Edge module, if it's something that is custom, like my Arduino module, that is a custom container that I did specify, and that's what I use. It could be a marketplace module. A marketplace module, we did talk about this a little bit, where you can have all these different, a SQL Edge, or you can run Node-RED in a container. You can run Redis on this Edge device. And you can have all these different modules. And then, of course, the Azure Stream Analytics module. So I created this Azure Stream Analytics module called ASA Edge Percept demo. You can also create a new one if you want to. So when you create a new one, you have to go through, there's some processes that you need to go, but you need to specify that the hosting environment would be Edge, right? And where it's going to be. Since I already created one, I'm just going to pull that out. Stream Analytics jobs. So I have that. And this is what it would look like when you create it. Since it's an Edge job, you need to specify a storage account. So you have to create a storage account, and you have to specify where you're going to store it. And then what is the key. You specify here what are the input. And so in this case, you have the stream input, and one of your input is coming from the Edge hub. An Edge hub input, remember I did talk a little bit about these IoT or hub, Edge hub that's running on that device. So the data would be coming from there. See if I can go back. So you see that Edge hub that's running. So data would be coming from here. I guess that's your local IoT hub. So you would route it, and you have an alias. You specify it as IoT input, and as it receives the data, you will have output, and you can add an output, and you can send it back to Edge Hub, or you can make it to blob storage or SQL database. In this case, we send it back to Edge Hub, and we specify it as alert. And in the query itself, and I did talk a little bit about this query, where you specify with the reader query, we select the label and the timestamp from IoT input, reading from IoT input the array elements of that neural network, and then getting anything that's a higher confidence level, and then have that as part of our output. And then the output would be sent into alert that would get read as part of that module. Okay, let me go back there again, where I specify the set modules. Under set modules, I added a Azure Stream module. I specify the Edge job. I hit save, and it would know that it would add these, like in this case, ASA Edge Percept demo. And on this one right there, it is using, of course, this is a container. It's running an image, and there's environment variables for this image. And then there's a container create options, and then module twin settings. the module twin settings has this ASA job info and resource ID. This is where it can download the Azure Stream Analytics job that would run at the edge. And how I know this link and where to put this link, I go into here, I would in Stream Analytics, and then you would have to publish it. And once you publish and say yes, it would generate the SAS URL. And now that you have the SAS URL, you would place that here. And then of course you still need you would need that information. And then hit apply. So once you hit apply, there are also a few things you have to know, and you have to change the routes. The routes are where the data is being passed from one module to the other. In this case, I am sending data from the Azure I module to Azure Arduino module. Remember that beeping a while ago when sending it to my Arduino? And how I do that is like your routing table where it says any messages that are coming out of Azure I module, any one of them, I send them to this brokered endpoint, and you specify Arduino module inputs input 1, and that's how it would receive it. So now if I want to send data outside to Azure I module to Azure Stream Analytics, I would do the same, where you specify from messages, Azure I module, where you specify the output, send it to this brokered endpoint, and this brokered endpoint, I specify the container name or the module name and specify IoT output. Remember this IoT output? That's the one that we named when we created this input, right? We specify IoT output. That should be the same name as your route, so it'll deliver it properly. Think about this as kind of like a topic, like an MQTT topic that it can listen to. And then any output of the Azure Stream module, I would want to send it to the cloud, to IoT Hub. So from messages that are coming out of ASA Percept demo, which is my module name, custom module name, I would send it upstream. And this upstream means it's sending it to IoT Hub. And then, of course, from IoT Hub, now we can process it and send it and to where we need to do the upstream processes. So after you do that, you click next and review, and this is what's going to happen. It will create these JSON file that would get shipped to that IoT Edge device, which is the Azure Percept, and it knows the instruction which containers or images to download and run, and that then the Edge agent is responsible for reading this JSON payload and then understanding the routing, what are the configuration that needs to happen on that device, and then the properties that needs to be set. And then so when you click create, and that's what it's going to do. It's going to send that payload to and update that, and it would update these modules and process it. Feel free to write questions in the chat. I will also be answering some of these questions if you have some. And then once we do that, once we know that there's IoT, we run the Azure Percept demo. It's already processing from Azure I module to that and then sending it to the cloud. Let's review where the data is going. Okay, so I have an IoT hub. I want to go to that IoT hub that I have, Percept demo IoT hub, And on this IoT hub, I am I configured it to where there's this message routing. This message routing, I created this custom endpoint, and in this custom endpoint, I specified that I want to store it in blob, and I specify where I'm going to do it and what is the encoding format. In this case, I wanted to try it with using these as a JSON payload, and it would give me these values. And it would be in this file format where we specify date and time. So once I have a custom endpoint, I can route data coming out of IoT Hub into these export telemetry data. So I created this, I click add, I specified which endpoint. In this case, I want to use this exported data. I want to specify the device telemetry messages. That means telemetry, that's the data that's coming from IoT hub, the coming from that device, and then it would send it and store it to blob storage. And of course, as it does that, as it receives the data, then I can do my processing later on. You can also do export. So that's what I'm doing right here. I can also create another route, right? It's not just storage, but also I can pass it to an event hub, or any data that's coming out of my device. You pass it to an event hub or a service bus queue or a topic. So you're not just limited to an Azure container. Okay. Let's go back to the presentation. So what just happened? I did demo um, in Azure Stream Analytics, IoT Edge, and some of the routings in IoT Edge, and so how to create or add the custom module specifically for Azure Stream Analytics, and how to deploy it to that device. I wanted to show you what the data looks like. Let me see if I can pull it up. Okay, so I already pre-downloaded the JSON file that gets created from the from IT from IoT Hub to storage server, and it would look something like this, where it is a JSON file. This is just the dump of what's the data looks like. You have the body, you specify the label here, and then count. So this is what you would receive from that device to, from, so what happened is your Azure Eye module did process and saw, the monkey, and from that, it did some machine learning, and then we passed the result of our inferencing to Azure Stream Analytics at the edge. It listen to it for every 15 seconds and count the number of times that they saw here, and then it sends that data or that report to IoT Hub, and then from IoT Hub we export that telemetry data into the storage account, and then we can do some processing here once it's sent to the cloud. All right, that's a lot of stuff. So just to recap, what is AI-enabled Internet of Things? AI, you learn from data. Internet of Things, your goal is to monitor and control devices. AI-enabled IoT is processing AI workload at the edge. And what is Azure Percept? It's an easy way to prototype and deploy AI at the edge. What are the capabilities of Azure Percept? You have Subvision, audio, and trust module. If you want to learn more about me, my name is Ron Dagdag. I am a uh, lead software engineer, director of software engineering, and an AI edge specialist at Spacey. I've been recently re-awarded Microsoft MVP. The best way to contact me is through LinkedIn, uh, Ron Dagdag, Twitter at Ron Dagdag, email Ron at Dagdag. I appreciate you geeking out with me about monkeys, Azure Percept, Arduinos, also uh, all things Azure Percept. Appreciate your time. Have a great day.